Hello, everyone, and welcome to Your Desk University, bringing you live learning with AEC tech experts directly to your desk. My name's Tim and Hazel, and it's been an honor bringing this show to you. We're at 19 episodes now, with one more to go, and we've talked about all kinds of things. We've had general conversations with tech leaders. We've had in-depth dives about Grasshopper and Dynamo, and PyRevit and creating documentation. Tonight's show is particularly fascinating because we're going to hear from 4 areas of the AEC industry about the fabrication, the design, and the research of facades in the future. So stay tuned. It's going to be a really interesting show. Before we get started, though, I do want to kind of highlight our next show, which is going to be on Tuesday of next week, and this will be our final episode of this semester. We are putting together a second semester, so stay tuned for that. And you can always go to our website, yourdeskuniversity.com, which you're seeing here. And at the very bottom, you can see there you can join us on Slack. And that's a good place to stay in touch and to talk with the speakers, talk with each other about where things are going. Our presentation on Tuesday is going to be about Dynamo with Autodesk, and they're going to be talking about things you may have missed along the way. So they know that our team here, we're not beginners, and so they're going to tailor that towards a more advanced crowd. And so I think you'll find that quite fascinating. With that, I want to jump to our presentation for today. So our presentation from today, you can see our presenters here. Everyone, wave to our audience. And if you are tuning in live, go ahead and say hi in the chat so they know who they're talking to. They are all watching it and moderating that, so you can ask them questions even while somebody else is presenting. We're going to be talking about the design automation and the future of building facades. And I do want to quickly introduce all 4 of them, and then I'll give a broader introduction to each of them as we go. But on the top left, you're seeing Kevin Miske. He is the founder and CEO of Building Blocks. He's our fabricator. So hey, say hi. Can you wave for us, Kevin, so they know who I'm talking about? Perfect. Next, below him, you're seeing Gustav. Gustav is a engineer, a structural engineer, or he works at Walsh P. Moore collaborating with structural engineers, but he's actually an architect. So he's kind of both at the same time. So Gustav, say hi to everyone there. Stansu is our architect for the day, and he works he works at Morphosis, and he's the director of design enclosures there. And he does a lot of different complex buildings, and you're going to learn from him about some of his projects. And above him, we have Nathan King, our pragmatic idealist or researcher, and he works at both Autodesk and teaches and co-directs a research facility at Virginia Tech. So with that, I will come back to Kevin and give you a little bit more about him. So Kevin is the founder and CEO of Building Blocks GFRC, a fabricator of glass fiber reinforced concrete. Has grown from 0 to 20 million in revenue in the last 3 years. Maybe one of your questions could be, how did he do that? Currently, Building Blocks produces 200,000 square feet of GFRC in their plant in Kissimmee, Florida, but they're opening another plant that will be 500,000 square feet in 2021 in Buena Vista, New Jersey, to focus on curtain wall panels there. So with that, Kevin, can you start us out as the fabricator, understanding a little bit about design automation and the future of building facades?
Absolutely. Tim, and thank you for the introduction. Let me share my screen. Is that working well for everyone?
Looks great. Yep.
Probably should get to the beginning of the presentation then, and that'll be even better. So, first off, thanks for everyone for joining. This is my first time doing a Zoom presentation. So, we're all learning new ways to conduct our businesses. But excited about talking about this. I love having the opportunity to talk about what we do at Building Blocks. So I appreciate you guys joining us. So when Gustav, introduced me to the topic today, I came up with 3 questions that are to answer the question that he posed. And really what I look at is, how can we use innovation in our AEC industry, and why is that critical to success of moving that industry forward? What are the risks that we deal with building blocks deals with as a manufacturer, a designer of wall systems, and then a contractor that installs those wall systems. And then finally, how do we use innovation to help mitigate the risks that we see in those roles? I'm going to start by talking a little bit about our perspective on the AEC industry. This is just shows the volume of construction dollars. The U.S. construction industry is 1.6 trillion in value. I think after what's happened in the past 3 months, we're going to see a little dip in that. But hopefully, the construction industry leads the recovery of the U.S. economy because of the robustness of it. Construction employs 11.2 million people in the U.S. And the built environment is the largest contributor to carbon in our environment. So it's something that's really critical to focus on when we look at sustainability. This is a graph from FMI. FMI is a consultancy that focuses on the AEC industry, and it's showing over the last 60 years, the value of work per hour adjusted based on the inflation. But what is relevant to this is just that, as you see from 1970s, first off, construction productivity is relatively flat, but in 1970, there's been a point where it starts going negative. And you look at construction productivity versus other economic sectors, and over the last 60 years, there's been 10% growth in productivity versus manufacturing, which has had 860% growth. So obviously, there's something about construction that that is hindering our ability to increase productivity. This is an infographic that McKinsey put together. It's part of a document that they did called Reinventing Construction, and it also looks at the loss of labor productivity. This is over a shorter period of time, so 2 decades. But what has happened in the U.S. is that we actually have negative productivity growth in construction. And that is, I would attribute it to a number of reasons. First off, I think we just have a lot more regulations in construction than what it was, decades ago. The complexity of designs are ever more challenging. Construction, I think, in general, has low adoption of technology. I think what the rest of my presenters today will show a counterpoint to that. And then we also have loss of knowledge in the construction sector. As the tradespeople in construction leave, as they retire, we're not backfilling that, and that creates a gap in our ability to effectively construct buildings. This is part of a study by FMI, and what they did is they went out to building owners and developers and asked them, what part of the construction project do you see as being the most challenging? And most of the respondents came back that the exterior wall is. And I think that speaks to why my presenters, or our presenters today, are such intelligent people solving such complex problems, focusing on the building envelope and the building enclosure. Also, part of the same article, the same paper from FMI, they looked at, what parts of the building, part of the construction process has the greatest opportunity for disruption. And, that what they came back with was that it's concrete and the building envelope and glazing. Building blocks is very fortunate that that's what we work in. We manufacture lightweight precast building enclosure systems. So that gives us great opportunity for impacting the way that buildings are built. I took sort of a pragmatic view. We as a manufacturer and a subcontractor, we're sort of at the end of the value chain within the construction process. So we are always focused on risks. And I highlighted here some of the risks that we evaluate on every single project. And I highlighted the one in the bottom, health risks, which is relatively new to us as about 3 months ago. But these are things that we think about on our projects as we get into them, and like, how do we find ways to address those risks, mitigate those risks, and decrease those risks? So our approach for building enclosures is, we really looked at the productivity problem and said, the way to solve that problem is through standardization, prefabrication, and modularization. So this is an example of one of our wall systems. What you're not seeing in this photo is you're not seeing that we would have insulation and a back pan on this wall system. So we design our walls like masonry curtain wall systems. So it's a full functioning unitized wall system. We also have gone to a smaller format wall. So we have the ability to produce very big walls, but we've decided that, being small and modular and lighter weight gives us an advantage over some heavier weight systems. That's something that, we're continuing to evaluate based on what's happened with COVID. It's been, COVID itself has been a disruptor, because the challenge on job sites today is the risk of going into the building, and going on to the hoist to get up to the building. So where we used to, I say we still do, but we're evaluating this. Our approach has always been to do GFRC as a curtain wall, so we'd be installing from the inside. But from a risk standpoint, that imposes new risks to us because of COVID. So we're evaluating going back to exterior mobilization of buildings and do the erection of the facade from the outside. But it just shows how, we're constantly, reassessing the risks on our projects based on the dynamic environment that we work in. So the drivers that, we see for standardization, prefabrication, and modularization, we look at, how do we become more efficient at building this facade and increase the productivity and raise the value of productivity by looking at increasing the labor from a job site to a factory. The building enclosure, is really an ideal system to look at as a manufacturing style building component, that we can take that building system and bring it into a factory and do something that's prefabricated that allows us to create efficiencies both in cost and in labor, and delivers something that's a superior product to that project. Today, most building enclosure systems, either they are heavy and bulky like precast, or it's a stick built system that is something that's assembled on the job site that leads to, low productivity, high labor, and potential for errors and low quality. In, building blocks, we have four principles that we're always focusing on when we look at innovation. The first is that, energy should always be conserved, and whether that is the embodied energy into that system, or the energy that goes into operating the building with that system. The next is prefabrication increases construction productivity. So the more that we can manufacture something in our factory and send a more finished product to the job site, it provides a net gain for that project, both on schedule and labor. The third is standardization versus customization reduces costs. One of the challenges that we have about where we operate within the construction and design environment is that everything is a start from scratch design. And so the more that we can find ways to standardize, even though it can be a custom facade design, ways that we can standardize our connections, standardize our framing, standardize our details, that creates efficiencies for us, and that reduces costs. And then lastly is, modularity provides flexibility without complexity. That we can build a modular wall system, but it doesn't mean that it has to be, a modular home aesthetic, that we can do things that are modular and still be, highly customized and beautiful. Next, we're going to look at a few global projects. These are things that are just examples of GFRC. This is not building blocks work, but I like to show a global perspective because GFRC is used much more extensively in the non-US construction.
And I'm going to give you a couple more minutes, Kevin, and then I'm gonna
Yep.
move on to the next person.
Okay. So I'll move quickly through this. So this Mumbai airport, 100% GFRC facade for the opaque surfaces. These are mushroom columns within that same facade. Just shows high level of geometric complexity. This is all GFRC. This is Thousand Museum, Zaha Hadid's design for a high rise in Miami Beach. I'm sorry, Miami City, and we did work on this project. And then another Zaha Hadid design. This is in Azerbaijan. It's a very complex facade, but that was constructed from the handover of design to the completion of the enclosure was 2 years. It's a very concise schedule. And Masdar City, another GFRC facade, which is a sustainable facade. This is a net zero community built in the Middle East. I am quickly going to run through a case study, and Timon, let me know when you need to cut me off. So we're going to talk about 11 Hoyt. This is a project that we're working on in Brooklyn, New York. It's a studio gang design. You see a lot of three-dimensional design there to their facade. Our panels are these, I kind of call them drapery panels. They have these curvatures to them, and the curvature gets greater as it gets to the bottom of the panel. Our challenge on this job was really to control tolerances. We can build a single one of these panels that captures this geometry, but all of these, this geometry is taken up from panel to panel. So where we introduce variance into our manufacturing is typically in the mold making. And so if our molds are not well detailed out and capture these transitions from panel to panel, we're not going to have consistency of that three-dimensional profile.
So I know our audience is really curious about how you form those dynamic shapes in the fabrication.
Well, we start with the digital process and we go to an analog process, and that's something that with the right capital we would change. So the way that we build these molds today is that we make gussets and we do bendable plywood with resin on it, and it's low tech and it's air prone. Here's one of our panels, but the future, where we need to get to is through additive manufacturing. So this is a Thermwood LSAM system, which is large scale additive manufacturing, that has the ability to produce molds for us that would be 3D printed with a polymer and then CNC machined to the finished product, which is greatly reduces our ability, or greatly increases our ability to control tolerances, and it gives us the ability to produce the negative, so we could go right into production on spraying pieces into a mold that is highly durable, that requires very little maintenance in between passes.
Yeah.
It's obviously a very robust machine, and that comes with a big price to it. But I think within 2 to 3 years, this is how we're going to be making our molds when we have these complex geometric designs, and this is going to be a huge improvement to how we do it today.
Yeah, I'm gonna actually cut you off there. I think
Okay.
that you have so much great content. I know we could go for hours, and each person does. But I think that really helps. I think as a designer myself, and I know a lot of designers watching this, it's just a good reminder of like, oh, when we're designing things, how buildable is it going to be, and what are they going to be the cost implications? So it's always interesting to hear from a fabricator. And I'm sure I already saw one question, which I'll leave towards the end. But that came towards you, or you can answer it directly in the chat there. So next we have Gustav, who's going to be sharing. He's from Walter P. Moore. He is a registered architect and partnered with Walter P. Moore, New York. He leads the computational modeling there for structural and facade engineering. He specializes in design computation. He operates really at the intersection of architecture, engineering, and computer science, as do many of us. He's interested in novel forms of collaboration and generally believes that technology is not always is an easy answer, but it's usually in asking the right question that the value really lies. And so with that, Gustav, go ahead, take it away. Again, we'll have to keep it condensed. I know this is a much larger presentation. I appreciate you guys, cutting it down. So thank you for that.
Yes, thank you, Timon. Thanks to the panel. Can you hear me okay? And you can see this slide?
It looks great. Yep.
That's a good start. Okay, so super condensed version then of the Walter P. Moore kind of role in this chain is to be the technical consultant and design partner to the architectural designer. So we sit right there between, you might say, someone like Kevin's operation and someone like Stan, who you will see after me, where kind of a lot of things are tied together between real world making and the physics behind it and kind of design intent. So what that means in, let's see here, there we go. That is a pretty enormous task, and we have many. This is kind of the different services that our company has developed in over the years. All the technical consultancy that supports architects and contractors. We have a lot of people working across different offices. Deep project experience across the world, and so I think that what I'm homing in on here is more like when there's this sort of enormity, I guess, of choice, right? And you still have to work together and you have to come to a successful outcome, of course, which is what we all kind of ultimately are aiming for. Even before things became, we got thrown this giant wrench in the works that happened a few months ago. Of course, not even like mentioning the health and the economic kind of impact to society, but just like how are we going to do our job going forward? We don't quite know yet. I mean, we have ideas and we've been doing it so far and it's been going well, but in the long term, I think we're all asking ourselves these questions, right? So, building starts at one point in history with a few shapes and a few materials, which this is sort of a matrix of that, right? And then quickly across history, it grows into this enormous matrix of choices that we have to try and stay on top on. So that leads just even within our space of consultancy, right? These are some a little subset of things that we have done on the structural and enclosure engineering side at Walter in the last 5 to 6 years, and you can see already the diversity of this just product typology, of geometry, of size, of scale, of material choices. What is like slightly less maybe evident is that some of these are in hurricane zones, some of these are in climate zones, and all that. So there's a set of parameters to account for, of course. And on top of all of that, there is a design intent behind that the architect needs to be happy with, the client needs to be happy with that in the end. So what makes us, what do we try to kind of contribute, so to speak? What do we think is like the good way, basically, of supporting kind of a successful project? Well, of course, we want to be a useful collaborator. So that could be anything from just being responsive to being open-minded to being kind of technically up to date with stuff, which brings me to the next point, which keep up and aka innovate. I've written that in smaller font because it's a very overused word, but this is like one of the prompts of this panel, right? So we need to keep saying that with full honesty behind it. And finally, also remember why we do this. We probably got into this at some point because we like buildings. That's the assumption for most of us getting into this, and it might be easy to forget that sometimes in the depths of some tricky problem or organizational situation. So to be a useful collaborator, that could be anything from like when you have this and you have to get via this to that. How do you actually bridge that gap? Well, you might find yourself in a situation in which you have to literally bridge that gap from a kind of certain level of granularity or detail into a very detailed version of that, and ultimately construction. And we do, by a series of technologically enabled kind of processes, manage to bridge that gap when we insert ourselves, in what we think is the most successful kind of use of our skill set in our organizational matrix. When the design process looks like this, and this has to become that, and Dave Matthews Band has to play there 15 months after it was a napkin sketch, basically. Again, how do we kind of leverage technology in a series of ways so that can happen and that the product can stay on track? when the org chart looked like that, right? We try to keep up with both innovating, just keep up with what other people are innovating, even doing our own version of innovation. For instance, when we observe that there is a consistent kind of issue with film enclosures like the ETFE here, which has certain spanning capabilities, it has certain light transmission, leads to certain solar heat gain, etc. You can't low-E coat this because the metal sputter will destroy the ETFE. And what many times ends up happening in projects is that you coat them like this. You got the frits and you got your fabrics and you got your kind of actual visual obstructions, right? Which may look like this. And so you might actually go into developing a new material that allows for that kind of coating that we have become accustomed to in terms of maintaining transparency but not having the high level of solar heat gain. In the process, getting a material that's 8 times stronger than conventional ETFE, that has a certain other, series of metrics that all sort of outperform other materials, which if you confront them side by side, you have noticeable reduction in substructure weight just because you can span longer and it's just a stronger material. This is obviously a consideration that we have thought was important even before the current state of affairs, and it hasn't become any less important since. Basically, how do we reduce our footprint and our material use? One would be to innovate on the material side. You can also
Gustav,
see
there's
things
a
like
slight pop on your audio. I don't know if it's when you're further away from your computer or not, but it seems to go in and out. Just
okay.
Not that anything you do, just maybe be closer to your computer is my only guess.
It's actually this here, this mic. So it's always at my face.
Okay.
Supposedly, I'm not sure. Shall I? Is it unbearable or should I keep going?
No. Just keep going. Sorry about that.
Okay. No, that's perfectly fine. I would not want everyone to just be listening to.
Sorry, everyone. I know it's bearable. It's not perfect, but we want to keep going. So keep going.
Okay, that's good. The other aspect of that could be to try and innovate in a very traditional and well-known material, such as here, when we actually try to kind of devise a post-tensioned version of a material that traditionally does not want to be in tension at all, which is terracotta in this case. Doing that in collaboration with Boston Valley Terracotta and University of Buffalo at their annual ACAW workshop, which is an excellent event. This is a more recent installation of that same one where we assisted the team from KPF. The first one there was Studios in Pelle. This is the team from KPF that wanted to kind of experiment with glazing and extrusion based on a project that they had were about to complete at the time, which is One Vanderbilt in New York. They wanted a sort of different kind of take on this extrusion in its in the spandrel panel, which is what these graciously generous student assistants are holding up here in the 3D printed version for spandrel. So that could look like this when we again try to be a useful collaborator. Kind of set out the parameters for casting that into a precast backing, and in a future iteration of this, and with Kevin's help, we're going to do it in GFRC. It's been decided. And finally, remember why we do this. When you get to go on a sunny fall evening to a project that has been completed, and you see what a tremendously successful public space it has become, you might be thinking of all those Rhino models that have been spinning around on your screen. But ultimately, this is what you see there, and hopefully you'll think that it was worth it. So with that, I will say thank you.
Wow, that was a lot you threw in there. Thank you so much. Good timing on that. Remember to bring your questions. Gustav will be moderating the chat as we go. Gustav, there was one question I'll just add to this: is when do you bring a fabricator on? Since Kevin was just speaking and now you did. How do you decide when's the right time for that? And I think that might be a good Stan question. So if you can start and you can punt it if you wish.
Okay, I think Stan and I agree on this, but we'll see. As Kevin knows, we will always advocate for design assist when we can, meaning to have a capable and suitable fabricator on immediately who can advise on solutions that are directly compatible with their capabilities, whether they be, to Kevin's point, they're just the sort of scale of operation, to mold making capabilities, to whatever it may be, right? It's still something that, so we will, invariably advocate for that in any case where it's even remotely reasonable. It's still hard, especially I think in the US market, the way that procurement works, to just get that through, because it's perceived as a cost, an upfront cost that, the client somehow thinks that it's not going to come back later if you skip it at the start. So it's an uphill battle for sure. But the answer is day one if we can.
Yeah. No, that's great. Thanks. And with that, I will transition to Stan. Stan is our architect. Thank you, Stan Su, for joining us. He's the director of enclosure design at Morphosis. His primary role is oversight of complex enclosure systems. Mr. Su works in close collaboration with the team, ensuring that design quality is upheld throughout the virtual design and construction process. And I know that probably takes a lot of collaboration between different team members. His recent focus includes Orange County Museum of Art in Costa Mesa, California, new U.S. Embassy campus in Beirut, Lebanon, and the Colon 1, I hope I said that right, maybe you can correct me, and Only Tower in Seoul, Korea. Stan, thank you so much for joining us as our architect. So with that, what do you have for us for this conversation?
Let's see here. So, well, I just want to make sure that you guys are seeing the screen. I can't seem to pull it up. 1 second. Yeah, I'm having some difficulties here.
Difficulties with your sharing your screen. Can you share it at least as like a partial screen, maybe not full screen mode?
It doesn't show up on my. I see screen, whiteboard, and iPhone, iPad as a option.
Gotcha.
Portion of screen.
So in the Zoom screen at the bottom, you're not seeing the green arrow that says share screen?
I do, but then okay, can you see now?
Yeah, that looks great.
Fantastic. So
thanks, Dan.
Yep. One moment. So basically, I just want to talk to basically what everybody has spoke to at first, and I think really we are in line with all of this. I think there's a lot great things said, and it's great we start with the manufacturer first, because these are all considerations. This is a collaborative sort of effort in order to kind of reach the demands that we're trying to do. Sustainability. How long did it take for BIM to become ubiquitous? These tool sets that we use. And so I think collaboration's hyper important. We try to do some sort of early contractor involvement or design assist, some form of integrated delivery. But as Gustav said, this is oftentimes a challenge. It depends on every project, where you can sell that, where you can't. And if you can't, you try to leverage that with things like the workshop or research like we're doing now. And now, this is what we're all dealing with. So everything from the job site deliveries to how we interact are affected in some way. So just a few projects here to talk about some of the processes and the attention that we focus on. Perot Museum of Nature and Science in Dallas, obviously precast facade. And really what we're talking about here is a traditional material, traditional forming methodology. Precast hasn't been exciting really since, I guess, like the 60s, 70s, really pushing it then until, it's been really conventional to this date. So really this project, the client was really into the idea of going, having some skin in the project, some risk, right? And this client was a very traditional manufacturer. We worked hand in hand with them to develop a process that could achieve a certain amount of variability and complexity, but working with their sort of methodology in forming. Typically here you see some silicone molds, but the whole key here is, right, we've got 4 panels with a whole bunch of different inserts that are opening up the possibility of variability. This project was recently completed in Korea, where we have FRP panels acting as sunshades. So, sustainability, a huge driver, solar shading, analytics, the digital tool sets, letting us communicate with all our different specialty consultants, fabricators. But really, it all comes down to sort of putting the work in and and sniffing out where we're working, regional sort of demands, limitations, those sort of things, preferences and methodology. So as advanced as we are, these guys are, equally enamored with being advanced, but you will always find some part in the project here, they're doing automotive, aerospace, technology, sort of influence processes, right? From automotive, the model clay putty. But really what this is talking about is leveraging that control using the technology. I think Gustav said it well, where once you have vetted this stuff and you have really kind of done your homework, there comes a certain level of confidence in that this file that they're using is actually the file for fabrication that came from us, which was a design file. Once again, where everything hits the pavement, I think Kevin said digital to analog, right? We're using the most high tech processes that are available in many cases, but it all comes down to the lowest common denominator. And here's the material limitations, fabrication methodology. You see how it is still a hand sort of method. The last one I want to touch on is stems from this sort of collaborative research effort, and we actually partnered with Walter P. Moore on ceramics workshop at Boston Valley and University of Buffalo this past year, which actually coincided with when we were developing this facade, and really constructability and everything, and knowing the formability limitations of this material was really the real sort of challenge here. I mean, we're really talking about a hand laid terracotta facade, trying to find efficiencies in their system of forming panels. And there are just many panels, right? There's 4,300 flat planar panels and about 1,500 curved. And a lot of trim panels. Like, the logistics of this is just, daunting. And we talk about risk and how do we mitigate risk. And it's really kind of one of those things. It's kind of this one today. Only today we've got over the hump of seeing these pieces cut, and we actually to preserve the design, we had to actually change the pattern to work with the material. So here you see the materials, the pattern is weaving all about, and the reason for that is that we are taking developable geometry, laying a grid on it when it's flattened, and rolling it back up. So in that sense, we only have essentially one panel type in fabrication, which is great. And those guys are happy. I mean, not including the curves. So real quickly, Walter P. Moore on this project.
I was like, wait a minute, one for all these different curves, but you're saying like the layout itself is one, but
it's how you sell it, right?
I'm calling you out. That's right.
But the funny thing is in these processes, it really is that to somebody, right? If there's these things about scope, and they were happy to like not get involved in actually the trimming and this and that. And so these are all negotiations. These are all, do we want to field cut everything in the field? Ideally, no. But what's the reality of fabrication, right? And vetting all this stuff. I mean, what you see in the upper left is Walter P. Moore's model, which we work hand in hand with these, because it's only skin deep, right? It has to be the whole assembly, and it was really a sort of a holistic effort as far as all the sort of components and layers that go into this facade. And so now today we sort of crossed the hump. We sort of seen some test cuts. We're going to get to the VMU. It's really like, as you go incrementally, you start to check off these boxes that are risks, and really I think it's really telling in that how you use innovation is or how you achieve innovation is really kind of many ways just sort of building upon existing sort of methods, and really catering them to a specific end. So to that end, I want to give it up to any questions, or Nathan. I know we're getting tight on time here.
Yeah. Thank you, Stan. That was really great. I think you showed this really interesting intersection between a fairly old material like terracotta and a new technology. There is a question here. I'll let you look at that in the chat. But I actually have another question as we transition to Nathan presenting, and that is, how do we what is and then this may be a Kevin question, but what does fabrication of terracotta in that type of form look like? How do they make that a reality?
Yeah, absolutely. So the initial design was all waterline joints, horizontal. Of course, with all the different geometry, this increased even more types of joints. So really, you couldn't do any kind of post-processing. The most efficient way that they can produce panels for architectural cladding is typically extrusion.
Mm-hmm.
So it's really focusing in on extrusion processes, molds, and it really is a tricky thing.
Yeah, thank you. And definitely keep coming with the questions. They will be moderating the chat. We'll try to get to those at the end. Thank you for all everyone's engagement. Also, I hate to say this, but YouTube really does want us to increase, like, I guess I'm just saying, if you want to help share the news that this is a good presentation, the best way you can do that is to hit the like button. I feel cheesy saying that, but otherwise YouTube hides this presentation unless people have a direct link. So that would be my request there. If you've found any of this helpful, go ahead and do that for us. And with that, we have saved potentially the best for the last. I haven't seen his presentation yet, but I do want to get to Nathan. Nathan King is both a senior AEC industry engagement manager for the Autodesk Technology Centers and the co-director of the Center of Design Research at Virginia Tech. I don't know where people get time for these kinds of things, but that's incredible. With a background in architecture and industrial design, Nathan earned his Doctor of Design from the Harvard University Graduate School of Design, as though all these other things weren't enough already, with a focus on additive manufacturing and robotics in design and construction. He's also one of us, as you can see. I love that in his intro, he told me that in addition to making things with robots, he works in sub-Saharan Africa developing and implementing new building technologies that help meet extreme demand for distributed healthcare infrastructure. And so with that, he's going to give us his thoughts on the future of building envelopes and automation. Thank you, Nathan.
All right. Thank you. Sorry to disappoint, but I want to change up my presentation a little bit and try to stem some discussion here. So I'm going to go through, I'm probably going to try it and fail, but I'm going to go through, try to go very quickly so we can have some discussion. But it's been brought up before, but collaboration, the merger or the collaboration between academia, industry, and design practice, I think is critical for actually realizing future of design, whether it's for envelopes or structures or design to construction workflows and so on. And I think we have a huge opportunity with the resources that academic organizations are putting forward to actually innovate in industry. So by connecting them, as Gustav said, asking the right questions, or someone maybe put those words in Gustav's mouth, but asking the right questions is critical. And I think asking them across the disciplines is important and across the sectors. Collaboration and diversity is also something that's going to drive the future of automation in relation to the technologies. These are all people I've worked with. If I've worked with you and you're not here, it's a graphic choice, not a, nothing beyond that. This is the number of faces fitting on the grid, but I think it's important. And our panel doesn't necessarily represent this, but the diversity that's showcased in the development of new robotic technologies, startups, things like Dusty Robotics and others that are kind of pushing the envelope about what it means to work in construction and what it means to develop technology for construction. Kevin shared a similar slide, so I'm going to just reiterate that we got to figure out a better way to innovate in construction so that we can meet an increased demand that is estimated to require about 13,000 buildings a day between now and 2050, and enough transportation infrastructure to wrap the Earth 30 times per year to meet population demand. Right now, we're in this kind of weird situation. So stealing a slide from Stan, we have workflow innovation out of necessity. While we all see this as a challenging time, it's a time we need to think about this as an opportunity. Rather than cutting research budgets, let's increase them. And then stealing from Kevin, I want to reiterating, and I actually took out 5 slides that Kevin summed up here. The same drivers that are listed here for standardization, prefabrication, and modularization are also similar drivers for the use of automation. So material waste, skilled labor shortages, performance demand or green construction, improving safety, worker safety, worker productivity. We also talk about automation. Every paper I read and every paper I write, we talk about emerging design technologies and emerging fabrication technologies. Just a reminder that these things have been around for quite a while. We've been, the field of construction automation is rich and long. We also see automation, playing a role in areas we wouldn't expect it. So outside of some of the projects, that Gustav showed in his grid, we also see automation happening. This is a hospital being built in Zambia where the entire structural light gauge steel frame was built using an automation technology. We talk about robotics for design, so using design robotics to present new opportunities for designer to steer customization and kind of new opportunities using technology that we're able to access now because of design to fabrication workflows. We see productivity improvements or enhancements. This is a project or construction robotics in the top right, and their semi-automated mason platform, which is actually a robot. Shows up on site and works in collaboration with masons. And in the bottom right, some teleoperation research happening in the Autodesk Robotics Lab, thinking through how to build in crazy spaces, like space, but also how to separate the user from the hazard for increasing safety. We also see these things deployed across different form factors. We see technology adoption or transfer, where we have industrial robots that are moved into the construction sector through some modifications and adaptations. So AI Space Factory, in collaboration with the Center for Design Research and heavily supported by the Autodesk Technology Centers, was able to modify an industrial robot to mount it on a platform so that it could 3D print this 1/3 scale version of a space habitat. They were the winners of the NASA 3D Printed Habitat Challenge for this project called Terra. We have Boston Dynamics creating pretty incredible robotics technology that's looking for an application. So we have technology producers that need collaboration with the construction industry to create innovation. And then we have people developing construction-specific equipment, like this yellow machine on the right-hand side, which is a machine developed by Apis Core to 3D print concrete. I'll throw out some questions here. Is the design concept a driver for complexity? So we have all these new tools. Is it helping us achieve complexity? Stealing a slide from Gustav. And then how do we meet the demand of 13,000 buildings a day while allowing for design flexibility? Just throw that out there for some discussion. We have design intent, this crazy bird's nest facade system that was a design proposal by a student group working with the Center for Design Research for a real-life project in Prince William County, Virginia. What that does is it actually serves as a vehicle for some computational research around workflow optimization. Here we're overlaying, or actually the graduate student Pablo Cabrera is overlaying stress curves with some optimization for daylighting to result in this crazy thing. And so we have performance driving this, and we could talk about the efficacy of the simulation at some point, but performance driving this crazy thing. And the question is, how do we make it? So now we have a computational design workflow that links performance optimization to robot code. And here the automated workflow is pulling the individual cut paths for the robot, the things on the left are robot targets, ultimately resulting in an industrial robot with a milling machine on the end of this, milling spindle on the end of arm. And I'll throw in there, that's actually one of the great opportunities with the robot is that end of arm tooling can be customized depending on what the process is. So Kevin mentioned additive in the future of formwork. There's some other projects that were shown. We also think about the efficiency of assemblies. This is a wall panel. This was intended to be a spandrel panel, actually relating to the project Gustav showed, as the work with Boston Valley. But here we have a wall panel. And while we know the robot can pick up all the parts of the wall panel, we don't know that those wall panel components are going to be in the same spot. So working with Dan Tish, who's a candidate for the Doctor of Design degree at the GSD, and also works with us at the Autodesk Technology Centers on research relating to robotics and construction, is working on vision-guided robotic placement for curtain wall assembly in this case, but can be applied to framing assembly. So how do we actually deploy a robot on site or in a factory and maintain tolerances, resulting in proof of concept here? A mobile robot delivered the parts to the industrial robot. The industrial robot identified them and placed them, as a microcosm for what might happen on site. And we've got about 10 minutes left, so I'm going to quickly burn through this. But this is an academic project here, a solar decathlon project called the Lumen House. This is the design proposal. If we want to move beyond the academic environment, we've got to figure out a way to actually automate this process. This is a customization project relating to an academic research trajectory that was ultimately deployed by Zaner with help of others, and the Bloomberg Center that Stan is familiar with, project by Morphosis. And then we also have to think about how do we transfer these technologies to areas that have different resource spheres and supply chains and resource limitations. So this is actually the same computational design workflow deployed on a project in Haiti in collaboration with Mass Design Group, and this is Mass Design's Color Treatment Center in Port-au-Prince, Haiti. And again, these are all representations of collaboration between academia, industry, and practice. And I'll close with this slide that just hopefully you can read it, but talks a little bit about the residency program that we offer in the Autodesk Technology Centers that facilitates this collaboration. It's a very quick and dirty, try to get it done in 6 minutes, but I really would like to hear some discussion because there was a lot of polemics presented, I think, during the conversations.
Yeah. Thank you so much, Nathan. I think one of the things that brings to me is, and maybe you or maybe somebody else has the question for this, but like, what is currently limiting us? Like, how can we move to the next step, right? And remember, like, most of the people watching this are sitting there going, yes, that's what we want to be doing. We want to like, we're ready. But is the industry ready for it? And it seems like it is in some spaces, and it's not in other spaces. And I love how it was kind of shared earlier about how there's this combination of some things being, digital and some things being manual, and there's some kind of intersection there. But yeah, so I guess the question is, what can we be doing to help this movement?
Is that a question for me? I guess
Go for it.
I can answer that. One thing I think that is again, and I'll say this about 100 times, so I apologize, but the collaborative opportunity is real in that there's a lot of really great stuff happening in universities. We can all say as practitioners, though, like, are these things, is this real? And how do we apply this? And I think that in industry, we say, how do we afford this? How do we actually deploy this? And how do we take time away from billable projects to produce research?
Mm-hmm.
And what would be helpful is for industry, like the folks on this grid of people here, to collaborate more with academic teams to help steer some of that research such that it's asking the right question. As Gustav, we'll give Gustav credit for that, asking the right question. And I think also that collaboration would allow industry to do more with less in terms of, we don't have resources in industry necessarily to build out a robotics lab. Every design firm can't build a research facility, but most academic institutions have them.
And what would be like a good way for a designer to connect with a researcher? I know one of the questions that came in is like, what's a way to collaborate in this time? Are there virtual ways they asked specifically about for students, but also for like, professionals? How do professionals connect with what you're doing?
So Stan's slide, I think, was great with the kind of the multiple, remote meeting happening. But with the residency program and the technology centers, we've gone totally virtual in light of the situation as we work to reopen our workshops. And joining a virtual community like the Technology Center Residency Program, and there are some others, gives you immediate access to software engineers, structural engineers, design practitioners. So for students and practitioners alike, this is a forum for people to engage in collaboration, even though we can't be in the same physical space. And I think that's the reality now. And I think the more of this kind of thing we do and the more dialogue we have, the better. So whoever asked that question, send me an email and figure out a way to get you connected to these people.
Definitely.
Yeah, I think a lot of it is, like Nathan said, is like kind of finding that dialogue. And what's interesting is that even though we're physically separated now, it's this sort of immediacy that we have with the technology that we're now forced to use to its fullest as we can. And, you know, I do see even more sort of, I don't know what you call it, but kind of grassroots kind of technologists coming together to find ways to collaborate, right? And not always will there be someone like Boston Valley Terracotta or a manufacturer that is pulling together all these different types of people from different industries in AEC. And so you kind of, I think, look for that and you start spearheading that. I mean, even amongst us, it doesn't happen enough, but we talk about, you know, and we do time to time get together and talk and have drinks and you know, set up these sort of things, you know, the workshops and conversations, and you know, hopefully these things you can use in your work
Yeah.
eventually.
Yeah. It related kind of, but yeah, just talking about some of the things and some of the things that I've seen in the chat is, so there's been different things that have pushed innovation over the years, right? We've had like the elevator, we've had a dehumidifier, we've had just our normal spaces that we currently live in, and there's so much. At COVID right now, we know that's going to change how things are done. What do you see as the disruptors to innovation that are going to force a new direction? And I realize the fact that we all need to stay 6 feet apart is like a clear one, but maybe you could reach for another one, or what that application might look like in your opinions.
I think that I might go first there, just because you know, I've had these informal conversations, let's say, with friends in the industry over the past few months, and I have kind of come to the point where I can't see another um, floor plan of the new office of, you know, post COVID, where you basically get rid of 2/3 of the people, you put up cubicle partitions in the like in the 70s, and you have like Lysol wipes everywhere. Like, it's not like this is the tactical response, right? That's what you do just to get through the day, but there is a deeper kind of there's a deeper understanding of what drives the risk here, you know, both the real risk and the perceived risk, for as long as it's going to take still before we know exactly what um, where the appropriate level lies, so to speak. And you know, I mean, if I want to go from that, right, really sort of abstract, let's say, concept to something very concrete. So I was talking to a friend just before, who has a background both in mechanical engineering and in architecture. And you know, the so-called P-Tech units, right? The units that sit underneath a window and that has an air exchanger with the outside directly, sort of, it's like one step above the sort of apartment window unit of an AC that you would see in New York or other places, right? They have been sort of, you know, deprioritized for decades in favor of centralized systems, which are now turning out to kind of recirculate air and have a relatively poor record of kind of air management, unless they're retrofitted at great cost and whatever. So we may see you know, we may see something so trivial as something that was definitely kind of consigned to the boneyard of mechanical systems, right? What might come back again, because in its simplicity, it's actually potentially better than central air right now. And that actually has a, you know, it's got a spatial design implication as well as an enclosure design one, and of course a mechanical engineering implication. And these are things that, like, certainly, you know, I don't think that the right people are being called upon yet to give their expertise in terms of how to move forward with this. And I hope that that's going to start, you know, once we've gotten past the sort of tactical responses that we're still fully involved with now. I hope we can be a bit more strategic, and that involves, of course, people of our community as well.
Yeah, thank you. I would love to hear from another person. Also thinking about our next question. We have a couple more coming in, but our closing question I'm going to throw to each of you is, what would you like people in the other spaces to know? And obviously, goal is to keep that super short when we do close. But we do have a really great chat, and so don't forget to check in there and respond if I'm not getting to the questions that are coming up. But anyone else want to talk about the drivers of innovation? I think Nathan, you showed robotics. I think that's a technology that's going to provide for a massive implication. Kevin, you shared a little bit about that in your presentation. Any other thoughts?
I think, you know, one of the things we all talked about and is kind of like materials, right? And there's sort of these interesting dichotomies that are happening now. We're revisiting. I mean, terracotta is, we're not the only ones experimenting with it, right? It's been sort of uh, kind of regained more traction here in the States. And I think what's interesting to me is I'm seeing even with coatings and what we would kind of sort of thin shell, high performance, lightweight materials that in the past we sort of viewed at them as sort of being quote unquote fake. You know, so it could be like you know, a terracotta panel that weighs a tenth of the weight because it's actually bonded. It's only an eighth inch thick or something, and it's on a panel, or different ways that we develop materials, like kind of Gustav's example, where essentially you're creating a new product just based on reformulating things. So I think you know, finding innovation in that way is super ripe. Um, and and I would say that, yeah, a lot of the work that we do is analog in a way, you know, as far as how do, you know, obviously how do we utilize the tool sets and
Hmm.
whatnot. And then in sort of finding like sort of synchronicities and all these different processes that we try to employ. Um,
Yeah, thank you.
I'll jump in and talk a little bit about innovation as a manufacturer contractor. For us, it's very challenging. If you look at my peers in this presentation, Nathan is R&D, right? And Stan probably has a large allocation of resources for R&D, and Gustav, slightly less. And you know, building blocks at the end of that value chain has very little. And although our projects may be 2 years, 3 years in the making, it is a race. As soon as we get awarded a project, we're already behind schedule on it, and schedule drives everything. We can't take time to do R&D on an actual project, so we have to have that basically operating in a separate environment where we're trying to anticipate what things should we be researching that may become useful in our actual project environment. Because in that, it's tough, and you have to have a practice and you have to have a commitment for that when you're working, as a manufacturer contractor to continue to advance what you do.
Yeah. But in the reality is, a fabricator does have to create any design or
Yeah.
thought that anyone else creates, right?
Yeah, I would throw in there, like, I take it, Kevin, I take a little offense at it being just an R&D guy, because I would say that you're a guy that has
I'm
to,
backing off.
you have to get things done. In every one of these projects you showed, there's a huge amount of problem solving, and I would argue that, like, what you're doing every day is R&D. You just don't call it research, because you have to deliver something at the end of the day, and that's what I think you're actually. I'm kidding about the offense thing, by the way, just to smooth the waters. But I think that constant problem solving that you have to do, the more that you can communicate it to those of us that don't have to deliver a project on time, the more we might be able to research the right things instead of just
No, you're right.
doing things with robots. If that makes
You're
sense.
right. Nathan, you're totally right. We are constantly problem solving. We don't get to pick our problems that we want to solve.
Right.
That's the difference. We get tasked with something. We get a design. Stan sends us the design, saying, "I don't know how you're going to do this, but you need to figure it out because you're under contract, and you got these deadlines, and you got liquidated damage, so you better get going." Right? That's and then we have to figure out, and there is intensive problem solving in what we do. I wish that we had more opportunity to say, define what those problems are that we want to solve. But really, that's that because we're it's this waterfall process, and we're at the end of it. That's we don't often get to select what the problem is.
mm, mm, mm. Yeah, I think a lot of that is, yeah, just communication and understanding. You know, I fall fall definitely prey to at times, we talk about risk, and for each of us, because of our scope and responsibilities, risk might mean a different thing, right? But I think it's kind of finding that, working with people like Kevin and all the different type of specialty contractors, that really, just have to find a way that you can kind of understand the process, and I think it's really kind of the way this presentation was set up, is like you kind of have to understand what Kevin has to do to kind of achieve things before you can actually sort of demand certain things. And even so, that's tough, right? Because oftentimes designers, the risk is purely kind of more of an intangible thing, and I think what comes with it is just, they're not compromises, but it's sort of an evolution of your expectations and maybe goals as you go through this stuff.
Yeah. And I think that leads back to, what we were talking about, design assist, and how valuable that phase of a project can be, because that really becomes, our sandbox environment. Where you say, hey, this is my design intent. This is what I'm trying to accomplish. And then we have someone like, Walter P. Moore, like, okay, here's the performance requirements for this. And then, the input from the manufacturer, like, okay, here's some ideas that we think that we could test out to see if we can meet the design intent and the performance requirements for this project based on our understanding of material and manufacturing and construction. But, like we all have said, that is a difficult sell to building owners. They feel that there's not a positive return on that investment, and they put themselves into a non-competitive bidding situation, that they're not going to get the best value out of the marketplace if they become beholden to a single fabricator or contractor.
Right, right. And that's a clear, and sometimes, also building on that, we've had experience with OCMA where the CM did not have a good experience with design assist and early contractor award. So it all, it's kind of, we got to kind of look for the benefits. And I guess what I wanted to say was, in that instance, when we didn't have that formalized DA, we actually forced that to happen, and it's sort of like kind of going out, like kind of putting the effort out to go talk to someone that was willing to kind of partner with us in that sort of support or, research of an idea. So.
Yeah,
The things you guys,
I hate cutting this off. And
you
Nathan,
gotta
please jump in and throw your 2 cents in. Definitely. I don't want to go without that. And then after we close up this conversation, it'd be great just to just wrap up one thing you would like kind of other people in the other spaces to know before we close out. So thanks, Nathan. Yeah, finish up.
well, my 2 cents is more of a question. There was a great question that popped up in the chat that I think is relevant to this conversation.
Go for it.
Relating to industry segregation, and I wonder, Stan and Kevin and Gustav, I saw you come off mute, so sorry to interrupt that, but the things you guys are talking about seems to also relate to segregation within the different disparate components or people that are involved in the project. I wonder, I think that was a good question that came through the chat, but how does industry segregation play into this conversation about innovation, from Kevin, from your side, having to deliver a project, and Gustav and Stan working with someone like Kevin to deliver that project?
Well, I can give a sort of a tangential response to that, which ties back to the slides that I showed. So that experimental ETFE product that I showed was, and I failed to do that, apologize, was developed in collaboration with a chemical company named Medico, who, we don't want to be a manufacturer or material supplier. We do want to provide insight into what might be useful in the space of material supply, and whatever engineering and material science knowledge is necessary for that to kind of be realized by someone who knows how to make things. But it would not be, I think, it's a consensus in the company, it would not be conducive to the core business to also start making materials, like actually be the partner that, the party that someone contacts to purchase, X number of 100,000 square feet of that, right? So, there is a benefit in terms of like that everyone does their thing, and not everyone can do everything. I do not believe that is of any value to anyone, right? But to not, to not let that become like watertight kind of bulkhead compartments. That's the thing, right? And for that, I think you have a lot of it just has to do with interested people. You know, I'm sure it's a parallel also to like many people who are in this community of your desk are people who develop software at varying degrees of you know, distributable quality, right? But once you start doing that, then that's what you're doing, and it's not working, and people call you and they want to, you know, it's a bug and it's the middle of the night and it's not, you know, so you're like, then you're a help desk all of a sudden because you developed a product. And you might rue the day that you did that because that's not actually what you were trying to do. So I think it's still useful to maintain an awareness of what it means to be in various parts of a service industry as opposed to various parts of a supply industry. Or, you know, Nathan, whatever I know that, you know, Autodesk fundamentally is a product company, but the tech center has questioned that a little bit in an interesting way, right?
Yeah, I guess you can't. You need to know what direction. You know, how do we identify and help facilitate the future of, you know, this conversation we're having, and we can't do that in a vacuum. And so that's what the tech centers kind of enable, is a place for people to have this kind of conversation.
Right.
Only with hands-on real tools and materials.
Yeah, yeah. Which I hope you will find, you know, a strategic way back to, which isn't just like partitions.
Yeah. All right. So with that, I am sadly going to have to cut off this conversation. I know we could go for another 4.5 hours, and, you know, I see the chat is already yelling at me. But I think that means that they've really enjoyed it. So in closing, Kevin, Gustav, Stan, Nathan, thank you so much for being with us. Thanks for participating in this conversation.
Thank you, Tim.
And we will see the rest of you again, I guess, on Tuesday. And we will talk to you later. All right. Bye, everybody.
Thanks, everyone, for tuning in.
Everyone.
Thanks, guys. See you soon. Take care.